Today we are discussing the last part of a few questions left out in our model question paper for our NC, CET and NEET examinations. As I have told you in the last session also, I wish to repeat that again. Working at least 8 to 10 model question paper for NC exam will go a long way in facing your ensuing exam more successfully. Okay, students, we shall go to discuss the next question. We had discussed 35 questions in the previous class. The question number 36 has appeared on your screen. Go through the question and try to work out on your own. Anyhow, I will be discussing. You can give a small pass and try to work out this question. It is not very difficult. This question is taken from coordination compounds. So I have given you 3 complexes, NiCO the 4 times, neutral complex. Other 2 are anionic complexes, NiCN 4 times 2 minus, NiCl 4 times 2 minus. The question is, you have been asked to find the type of hybridization involved. All these 3 complexes are very much there in your regular syllabus. In fact, you have prepared yourself for these complexes for your board examination also. On that basis, if you are very confident about your memory, you can directly answer this question. You need not have to waste time. Otherwise, suppose you are not very confident, I will tell you a quick method of finding out the type of hybridization involved. These 2 are strong ligands. Halides are weak ligands. Weak ligands cannot pair up the unpaired electrons. Only strong ligands can do that. In fact, CO is the strongest ligand in our spectrochemical series. This carries 0. Remember, the atomic number of nickel is 28, means it is 3D8 4s2. 3D8 has got 5 orbitals. Because carbon monoxide is a strong ligand, it is capable of pairing up of all the 8 electrons. If 8 electrons are paired, only 1d orbital is left. Remember, 4s is not vacant, 4s is filled, 4s2, 4p is vacant, 4s is not vacant. Coordination number is 4. Hybridization should be either sp3 or dsp2 when the coordination number is 4. If you do not know this, make a note. When the coordination number is 4, the hybridization is either sp3 or dsp2. Yes, dsp2, but s is not vacant. So, carbon monoxide is such a strong ligand that it can push these 4s electrons behind, make this 4s vacant and undergo sp3 hybridization. So, this is sp3. So, our answer should start from sp3. So, second answer you can eliminate. Alright. Next complex, NiCN 4 times 2 minus Yes, the oxidation state of nickel is +2, correct? X minus 4 equals -2, X equals +2. Means it is 3D8, 4S is vacant, 4P is also vacant. Cyanide ion is a strong ligand capable of pairing up of all these 8 electrons. So D is left vacant, 4S is vacant, 4P is also vacant, therefore it undergoes DsP2 hybridization. In the previous case it was not possible even though CO was a strong ligand because 4S are not vacant. So the second answer should be DsP2. Obviously you can eliminate sp3, DsP2. Yes, we have either C or D. So we shall come to NiCl4. Again the oxidation number of nickel is +2, means 3D8, 4S is vacant, 4P is also obviously vacant. Cl minus is not capable of pairing up of these 8 electrons because it is a weak ligand. So no d orbital is available for coordinate bond formation. It has to undergo sp3 hybridization and there is no other goal. So the first one is sp3, second one is dsp2, third one is again sp3. So you mark the suitable option there and option D is correct. Think over, such questions are very common. Question number 37 is on your screen. The question is, which of the following compounds is not chiral? Means which of the following do not have a chiral carbon? Yes. This is fairly simple question. Look. 1-chloro-2-methyl pentane. The root word is pentane. 5 carbon atoms joined by single bonds. A. 1-chloro-2-methyl. 1-chloro-2-methyl pentane. Yes. No chiral carbon. Yes. Look here. These two groups are same. How about this? This is not a chiral carbon. Look at this. This carbon has got this group this side, CH3 this side, H this side. So the 4 groups attached are different, though this is a chiral carbon. So the first option has a chiral carbon, therefore it is not the answer. 1-chloropentane. 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 Look, these two are same, these two are same, these two. It is the answer. It has no chiral carbon. It has no chiral carbon. And that is the answer. As a matter of curiosity, I will test the next one. 1-chloropentane. Yes, option C, 1-chloropentane. Actually, I discussed C. 2-chloro, the answer is C. It has no chiral carbon. Option B is what? 2-chloropentane. 2-chloropentane. Yes, CH3, H, CH2, CH2, CH2. Look at this carbon. It has 4 different groups on it. Yes, that is a chiral carbon. So second one has chiral carbon. Last one, again pentane. Yes, what pentane is it? 3-chloro, 2-methyl pentane. 3-chloro, 2-methyl pentane. CH3, CH, H2, H2, H3. Yes, CH3, CH, this is H. Look at this carbon, third carbon. It has got this group, this one, this one, this one. All the 4 are different. Therefore, option 1 has a chiral carbon. Option B also has chiral carbon. Option D also has a chiral carbon. C is the one not having chiral carbon, that is the answer. So you should be able to write their structures quickly and make out the presence of chiral carbon. Question number 38. I think most of you might have worked out questions of this style. Which of the following is most reactive towards SN1 reaction? Very easy question. I think most of you can answer this. In spite of it, I will brush up your memory. Bulky groups on the halogen bearing carbon atom. I will repeat again. Bulky groups on the halogen bearing carbon atom favor SN1 reaction. Bulky groups on the halogen bearing carbon atom do not favor SN2 reactions. Smaller groups should be there so that they will not cause steric hindrance. So, methyl halides undergo SN2 reactions. CH3Cl, CH3Br, like that. Tertiary alkyl halides. Tertiary alkyl halides look, say for example tertiary butyl chloride, tertiary butyl bromide, like this. Halogen bearing atom is surrounded by bulky groups and it undergoes SN1 reaction. Tertiary alkyl halides undergo SN1 reaction. Primary alkyl halides including methyl chloride undergo SN2 reaction. Secondary alkyl halide is peculiar. Part of it undergoes SN1 and another part SN2. Both SN1 and SN2 are possible as far as secondary alkyl halide is concerned. Primary alkyl halide, as I told you in the beginning, favors SN2 reaction. So here we have asked SN1. The answer is tertiary alkyl halide is the one which readily undergoes SN1 reaction. Point to remember, bulky groups around the halogen bearing carbon atom promotes SN1 reaction. I hope you have followed this. This was a very simple question. Yes. Question number 39 has appeared on the screen. It is a question based on your memory. Remember, in chemistry, memory based and logic based questions both will be there. It will be an admix of both logic based and memory based questions. Memory based question, you will find at least 5 or 6. Question number 39. Benzene reacts with propene in the presence of phosphoric acid at 523 Kelvin to give. If you are well versed in writing the structures, benzene plus propene. CH2 double bond CH3. Propane. In the presence of phosphoric acid, heat, obviously, yes, it is electrophilic substitution. Yes, benzene adds to CH group and H to this. Yes, you remember this compound? This is isopropyl benzene, commonly called cumene. Isopropyl benzene is commonly called cumene. Yes, recollect, in what context did you study cumene in your syllabus? You have studied cumene under which chapter? Just to recollect, in the phenols chapter. Phenol is in fact manufactured on a large scale from cumene. Though it is not connected with this question, it's better to know this also. When cumene is heated with dilute H2SO4, yes, it gives phenol and acetone, CH3COCH. Hence, this reaction is used in the manufacture of both phenol and acetone. Both are industrially important compounds. So, the second part I told you is not connected with the question given here. It was connected with only first part. Benzene reacts with propane in the presence of phosphoric acid to give cumene. Question number 40, again taken from organic chemistry. Phenol can be converted into orthohydroxybenzaldehyde by orthohydroxybenzaldehyde. Phenol can be converted into orthohydroxybenzaldehyde. Yes, orthohydroxybenzaldehyde, this compound. Usually we write CH over the top. Usually you can write like this also. Usually it will be of this. Orthohydroxybenzaldehyde. Are you recollecting the common name we use for orthohydroxybenzaldehyde? It is salicylaldehyde. That is the one word for this. Salicylaldehyde is not IUPAC name. Even orthohydroxybenzaldehyde is also not IUPAC name. 2-hydroxy, 1,2. 2-hydroxybenzaldehyde is the IUPAC name. Common name is salicylaldehyde. I think you have recollected the reaction from which we get salicylaldehyde. Phenol can be converted into salicylaldehyde. Raymer-Tiemann reaction. In Raymer-Tiemann reaction, yes, I am just brushing up your memory. Phenol is heated with chloroform and NaOH, and finally acidified. Yes, it becomes 2-hydroxybenzaldehyde. Other reactions given also, I will just make you recollect. What is coal-base reaction? The answer is Raymer-Tiemann reaction. I am just making you recollect other reactions given in the question. Coal-base reaction, yes, just recollect. Carbon dioxide is passed into phenol at a temperature of 383 Kelvin and under pressure, and finally the product is acidified and you get salicylic acid. So salicylic acid, orthohydroxybenzoic acid can be obtained by coal-based reaction. Salicylaldehyde is obtained from Raymer-Tiemann reaction. Salicylic acid is obtained from coal-based reaction. Wurtz reaction, I think most of you are very familiar with. Two molecules of an alkyl halide reacts with sodium metal in the presence of dry ether to give a higher alkane. That is Wurtz reaction. A higher alkane can be prepared from Wurtz reaction. Canizaro's reaction is a property of benzaldehyde. Canizaro's reaction is a property of benzaldehyde. When benzaldehyde is heated with strong solution of NaOH, it gets converted into a mixture of benzyl alcohol and sodium benzoate. So that your memory is brushed up. Yes, from coal-based reaction can convert phenol to salicylic acid. Raymer-Tiemann reaction, phenol to salicylaldehyde. Wurtz reaction, alkyl halide to higher alkane. Canizaro's reaction, benzaldehyde to benzyl alcohol. These are the name reactions which most of the students are familiar with. So the answer was Raymer-Tiemann reaction. Question number 41 has appeared on the screen. Not very easy. You have to analyze and get the answer. Not a very easy question, but taken from organic chemistry. A compound A having molecular formula C5 H10O. This is the compound taken. Just recollect organic compounds containing oxygen, single oxygen, alcohols, ethers, phenols. Okay? C5H10O. C5H12O. C5H12O. This is the compound taken. Yes. This is subjected to oxidation. It gives, this compound is called A in the problem. This is subjected to oxidation. Then we got a compound B whose formula was C5H10O. Okay? Before proceeding, think what happened. Carbon atoms number remain unchanged, oxygen remains unchanged, only 2 hydrogen atoms are removed. Are you remembering what is the reaction in which hydrogen removed called? Dehydrogenation. I'll repeat again. What is the reaction called? Dehydrogenation. Yes. Try to think over in which chapter of organic chemistry, second year, we get dehydrogenation reaction. It is in alcohols. When a primary alcohol is passed over copper heated to 573 Kelvin, yes, it gets oxidized to an aldehyde plus hydrogen. Secondary alcohol, same reaction, gives a ketone plus hydrogen. Aldehyde's general formula is also CN2H2NO. Ketone is also CnH2NO. So CnH2NO, this can be an aldehyde or ketone. We don't know. So, a compound that undergoes dehydrogenation is usually alcohol. The alcohol can be primary or secondary. Primary, if it is a primary alcohol, we get aldehyde. If it is a secondary alcohol, we get ketone. So from this data, you get a hint. The compound A should be an alcohol, primary or secondary. Okay. Now we shall read the problem further. Compound B, this compound, gives 2,4-dinitrophenyl hydrazine, but did not answer haloforum test or silver mirror test. Silver mirror test is a specific test for aldehyde. It did not answer silver mirror test means it is not an aldehyde. It should be a ketone. If it is a ketone, alcohol should be secondary, not primary. Okay? Yes. Next, one more hint. Did not answer haloforum test. If any compound answers haloforum test, it contains COCH3 as its terminal group. At the end of the structure, there should be COCH3. Then only it answers haloforum test. If you don't know, you can better to make a note of this. Yes, a compound having terminal COCH3 can only answer haloforum test. If it doesn't answer haloforum reaction, it means there is no terminal COCH3. These are the hint here. Option A we shall rule out. Why? It is a primary alcohol. You have proved that it is a secondary alcohol. Option D, rule out. Again, it is a primary alcohol, CH2OH. So the answer should be either B or C. Look, so we have short lined answers. The option should be either B or C. Why? We have identified the given substance as a secondary alcohol. B is also secondary alcohol, C is also secondary alcohol. We have to find the correct answer. Suppose it is B. What is the structure of B given? CH3, CH2, CH2, CH, OH. If you oxidize this, it undergoes dehydrogenation to give a ketone. This ketone contains a terminal COCH3. Then it has to answer haloforum test. Therefore, B is not the answer. Come to C. CH3, CH2, CHOH, CH2, CH3. If you dehydrogenate this alcohol, you get this particular ketone. Pentan to 3O. Here it has no terminal COCH3. Therefore, this cannot answer haloforum test. In the question we have given, the compound doesn't answer haloforum test. Therefore, option C is correct. This is a skill-based question, and such questions definitely you find in your test. I will explain quickly once again. The molecular formula given is C5H12O. C5H12O means CnH2n+2O. This corresponds to the general formula for an alcohol. Alcohol means it can be either primary, secondary or tertiary. Look, this compound
is oxidized to get compound B. You must carefully observe the product B that you got. Product B and product A, observe them. Yes, product has, the reactant has lost 2 hydrogen atoms to form the product. Product contains 2 hydrogen atoms less compared to the reactant. That means the reactant has lost hydrogen. This reaction is called dehydrogenation. Dehydrogenation mostly comes only under one context in your syllabus. Immediately most of you remember dehydrogenation of alcohols when they are passed over heated copper. If it is a primary alcohol, it gives aldehyde on dehydrogenation. Secondary alcohol gives ketone. So B should be either an aldehyde or a ketone. What is said next? It gives 2,4-dinitrophenyl hydrazine test. This is called Borch test. It will be told in the class. Borch test is answered by both aldehydes and ketones. So 2,4-dinitrophenyl hydrazine test will not enable us to make out whether it is an aldehyde or a ketone, because both of them answer 2,4-dinitrophenyl hydrazine test, but did not answer haloform test and silver mirror test. Silver mirror test is specific for aldehyde. It has not answered silver mirror test, means it is not an aldehyde, it is a ketone. So, in all the 5 options given, all of them contain 5 carbon atoms. All the options contain 5 carbon atoms. Ketone group always appears in between. It will not be a terminal carbon atom. Ketones do not contain terminal carbon atoms. It should be on this carbon or this carbon or this carbon. Suppose it is this carbon, then it will have a terminal COCH3 group. Then such ketones answer haloform test. So it cannot be here, because had it been here, it would have answered haloform test. Suppose it is here, then there is no terminal carbon COCH3, this will not answer haloform. Suppose it is on this carbon and this carbon are identical. It is second carbon from this end, second carbon from this end. They are identical. So it should be on this or this. It cannot be on this, because had it been on this, it would have answered haloform test. This doesn't answer haloform test, means there is no terminal COCH3. So it should be, the answer should correspond to this. Means that the third carbon atom, primary alcohol, must be there. So option C is the correct answer. You work out this question again after this and ensure that you have perfectly understood this question.